Hi guys, how are you all?
Good.
Hey, class starts at
Good.
8, 7:15, right?
Yeah.
Yeah.
Okay. Okay. Hi Arihan, hi Datri, Hansh, hi Vaibhav, hi Charan.
Hi.
How are you all?
Good. Good.
Good.
Nice to
Good.
know.
Pretty good.
1 second, guys. One second, guys. Yep. Arihan, how are you doing, Arihan? Are you doing your homework?
I don't. I did wait. I did 8.1, 2, 3, and 4 exercises.
Oh, nice. Okay. Was it easy or hard? How was it, guys? 8.123.
They were very. It was good. The
It was
questions,
good.
if those exercises, it was
Easy.
pretty easy.
Okay, I see. What was it, Arihan?
Pretty easy.
I see. Good to know. Sarvata, how was it for you, my 8.123? Oh, 3 as well you guys completed?
What?
Yeah, 8.2
Yeah,
and 3.
that was homework last week.
Yeah. How was it, Vaibhav? You tell me.
Yeah, it was pretty good. I mean, it was harder than 8.2, but it was still doable.
Good. Okay, Viraj, how about you?
I did it all.
You did it all. Can I give you a question? Let me see.
For me, 8.3 was easier than 8.
Okay.
I didn't see that. We have to do 8.3.
Yeah, 8.2 and 3 I had given you,
Oh,
right?
I thought it was only 8.2.
Thought
Oh,
it
they
was.
did 8.2 like the week before that.
Yeah, that's what I mean, 8.1.
For
I
me, it said like
didn't.
8.2 and 8.2, so I just did.
You know what? It was my bad. I thought you guys will understand 8.2 and 8.3. Sorry, but somebody asked. I did answer that it was
Yeah,
8.
yeah, yeah. That's what I saw. When it said
Yeah.
8.3, 8.3, I was confused. So I looked in, and then someone asked 8.2 and 8.3, and then like you responded.
I just remember like the meeting, so I thought it was 8.
Same.
Really from my end, I apology, guys. Okay, because I did see since when somebody asked when I saw, I replied in class comment that it was 8.2 and 8.3.
Yeah, because I was like confused when I saw it, so I just like asked, and
I hear you. I should have edited that, right?
yeah.
Miss Priya,
Yeah.
are we doing those little project things that we said in class? Like
Oh yeah, I
needed mine. I made mine.
Wait, Miss Priya, since screen share doesn't work for
I'm
me,
not
can I just
ready.
send mine to you?
What was that, ma?
My screen share doesn't work, so can I just send my presentation to you?
Absolutely.
Sunnies.
Is today anybody is presenting today? You? Nice. What is that? What was that topic?
Sine, cosine, and tangent.
Oh, wow. Okay.
Mine is like kind of like graph theory and stuff like that.
Oh, wow. You started exploring?
Yes, it was like it's called the Seven Bridges of Königsberg.
That's a
Whoa.
good one, you know.
It-
Easy
Are you going to explain the seven bridges? See, I didn't know that you were going to explain the seven bridges of Königsberg. That's a good one.
all right.
Okay, I think we should start off with these presentations. I think they're really good. I need to hear them.
I
Yeah.
know, but
Mine
you
is
know
kind of
what?
big, but mine's pretty simple.
Okay, Dutt and Charan, you were not there last week. Okay, you know what? Guy, this group, they wanted, meaning I've noted down the names that wanted to present. So they will each present a project one week.
So can I go first?
Maybe.
I call dibs.
Wow.
Please, guys, there Aradhya is saying, oh my goodness, she says. So what do you want to do?
Since it was my idea, I think I should go first, guys.
I don't know. Then you and Aradhya should decide. Akshat and
I don't
Aradhya.
know.
Simple.
I don't know.
Mine is really
Okay.
simple.
Okay.
Elijah, you better say
Okay.
better say yes.
I don't. I don't.
You better
Okay,
say yes.
I don't have any opinion.
Yes. Okay, so
Oh.
she's neutral, so she doesn't count.
Okay, so I'd
No
say,
comment.
okay, the two people who might actually start presenting today are Aradhya and Akshat because they shared their ideas first. So either you guys do rock, paper, scissors, or either one of you decides.
Okay.
How do you rock, paper, scissors? in a
Honestly,
Zoom
you
meeting?
just go first because I still have to like figure it out.
Okay, mine is already done.
Okay.
Yeah.
Mine finished too.
No.
Okay.
Miss Priya,
Yeah,
I
ma?
sent mine in the private comments for the what is it? 8.3 and 8.3.
8.3 and 8.3. Oh, yeah. Sorry about it. It should have been 8.2 and 8.3.
Yeah, but I sent my presentation in the private link for that.
Oh, I didn't see that, Amma. Really, I didn't see that. I'm sorry.
just
I'll
sent
check
it.
now. Did you understand what was that?
Yeah.
Okay. Okay. Can I go ahead and give you one or two questions? Let's see whether you solve it correctly. Can we try?
All right.
Yeah.
All
Oh
right.
my god, my ears.
Okay. Yeah, me too. Me too. Let's see. I have some questions. Just 1 second, guys. My mission. Oh my gosh. Okay, we need to move to 10th. 10th is quite important, guys. 10th unit. Let's see, but we are moving slowly, I feel. Now it's October, huh?
That's October.
December. Oh my gosh. Oh my god. It is going to take a while. Okay. Okay. 1 second, guys. Okay. Any questions on the homework anybody had? Can I move on?
Yeah.
Any questions on the homework?
Like the star
No.
questions.
Oh,
Like
star questions. Okay, we'll do one or two, definitely.
the 8.3. Like those ones were kind of confusing.
Oh, okay. Yeah. 8.3.11. Now, 1. Did you guys solve?
Yes.
8.3.11. Did you guys solve?
I'm pretty sure I solved everything on
Yeah.
8.3.
Okay. No, do you want me to discuss those questions, or if you've already solved, don't waste time in the class? What? Tell me.
I already solved those questions, so
Already solved. The others?
Yeah.
Yeah.
Okay. How about this?
Yeah.
Okay. How about this? Okay, this one, let's see. This one will be a little difficult, guys. Not that easy as what you solved in school. How about this? Hey, Devansh, are you here? Oh, Devansh is not here today. Why? Interesting. Okay, go. Why Devansh is not here today? Go ahead.
Okay.
Mm-hmm.
Miss Priya, is my answer right?
I'll check more.
Is my answer right?
That's right.
my answer right.
Ayyo. What
Hmm.
guys? Akshat.
Is my answer right?
Yeah. See, the rate at which your answers are coming, I'm not able to follow through. Okay, Arhan, correct. Avi, positive, negative, everything is valid. You're doing AOPS pre-algebra. So, can you correct and send it to me? Vihan, that's incorrect. Arihan, that's correct. Good job, Arihan. That, not really that. Avi, correct. I'm waiting, guys. Vihan, did I check your answer, Vihan? Vihan, not really, Vihan.
I sent my answer.
Yeah, man.
Yeah, me too.
Neil, is your sign correct? Akshat, is your sign correct? Kabir, that's not right.
Oh, I see.
Charan, that's not right.
Oh.
Aradhya, that's not right. Vaibhav, that's right.
Hey.
But is the sign correct?
I see what I did.
Isn't the answer?
Oh my God.
Oh, I
Auntie,
see.
I forgot to add the zero.
I see my
Auntie,
problem. What is it?
Auntie.
Deepest recess
Auntie, I forgot to add a zero. My bad.
of my mind.
Okay, good.
And
Oh,
I solved the
yeah.
problem.
Auntie,
It's an
my
overall percent
Yeah.
change, so I didn't really get it.
Very nice. Or percent change. Yeah, it's minus 10%, guys. Did
How's
anybody? Viraj, where is your answer, Viraj? Sarvata, I didn't get your answer.
No, I sent my answer.
Yeah, sorry, Miss Priya. I thought it was like increase and then increase. I didn't see actually the decrease part.
Yeah, Auntie, I forgot my zero. Like my
I just sent
it
my
doesn't
answer.
work. Like Auntie, my zero key didn't. So I just
I
couldn't.
thought when it said
Okay.
overall percent change, I thought you didn't have to put the minus sign.
Miss
What is the overall percent change, right? Either you need to say 10% decrease or you can say minus 10%. Both are valid. Make sense? Can we move on? I think you all got the hang of it, I feel. Okay, that's good to know. Okay, I wanted to have a few more questions. Liters of each, you should mix 2 of 10, 30 liters. That's a little difficult question. I don't want to give you that. Okay, this is a good one. How about this? It's a tricky question. Okay. Okay, how about this? Try this one.
item A?
Go ahead, guys. Yeah, I want you to try that one. You guys can try this one. There's of the 60% acidic solution. Yeah, I really want you guys. I know that this is a little difficult problem. Next one, guys, okay? Next one is seriously a difficult problem, but you guys can write the equation for me. Let's try. I don't know about this. Item A costs 25%
Auntie, is
more.
my answer correct?
What percent more than? Ma, 1 minute, ma. I'm just reading the problem. Just give me 1 minute, okay? Item A, item B. What did I do on that?
Yeah, I sent my answer.
Percent, okay. Not really that. Ah, perfect. Saket. Nice.
I don't really get it.
Vaibhav, no Vaibhav. Aradhya, no
I
Aradhya.
don't really get it.
No
Yeah,
problem.
me neither.
No problem at all. I said these are difficult questions. Yes, Arhan. Arhan, I would like you to explain. I know Saket, you got it, but Arhan, I would like you to explain. Arihan, good job.
Is my answer correct?
Sarvata, not really. Kabir, not really.
Is
Everybody
my
got it. 23. No, Akshat, you're rounding too much.
is my answer correct?
Neil, okay, I'll go with you. Avi, what you understood, you solved it, Avi, but the answer is incorrect. You have not answered to the question. Hey, many of you have a 25%. I don't know where you're getting this 25%, but I'll let Arhan explain. Arhan, go ahead and explain, Arhan.
Okay, so I just thought of item B as $100, so item A would be 75, and then 100 minus 75 equals 25, and 25 is 1/3 of 75, and 1/3 is 33 and 1/3%.
Wait, that was my answer.
To percent is what? 1/3 is what percent?
33%.
What you guys forgot is 25 is not the percent. It is more by 25. So 25 is what percent of the original you have to find. Did you guys get it?
Yeah.
He explained it very well. So item A is 75, item B is 100. He's assuming, see, he started with 100. Percentage problems always can start with 100. If item B is 100, then item A is 75 because 25% less is 75. Now, the difference is 25. That 25 is what percentage of item A is what you need to calculate. Everybody forgot to do this step completely. Many of you have answered as 25. 25 is just the difference in their value. Can I move on? Okay, now comes the hardest question in the world. Let's see. Let's see if you are able to do it. This is an algebra 1 question though, okay, but it doesn't have to go to algebra 1. It is just equation solving with a single variable. Okay, I'll give you a clue if everybody is stuck.
Wait, can we have the clue after like 2 minutes? So like,
Oh,
we can see it first.
Sure. It's not an easy one, but yeah, meaning you can do only with a single variable you can solve. You don't need to go for 2 variables and all.
Is this like, are you saying like each, like are you saying each of these
Does the percent sign like mean of the number or the acid?
acid, I think.
Wait, Miss Priya.
Why do repeat your question? Does the
Does the percent sign like 70% acid, like does it mean like the number or the like acid?
Miss Priya.
acid
Auntie, is my
the
answer correct?
acid quantity present in the liquid? Acid quantity should be 60%. Acid quantity 40%. Acid quantity 70%. Yes, Aradhya. Go ahead.
How are we supposed to know the amount of liters in each solution?
Yeah.
Because
So I
I
just
thought you
take
have
it.
30 liters. Now you have to find out where to mix each one.
Oh,
Yes,
okay.
like 40%.
Auntie, is my answer correct?
Miss Priya, can we make like a ratio and then like average it like and then increase it like that?
It's not that hard.
Oh, okay.
Okay.
Auntie, is my answer correct or not?
No,
Is
she's
your answer? Oh my God, you guys are too fast for me, guys.
fine.
When I finish the test 80.
Oh my goodness. Okay.
Hey, Auntie, bro.
I still have my water.
How much liters does each acid solution have?
You don't need to know any of those, Vaibhav. You can just frame equations. Okay, that's why. Can I give you a clue?
Yes.
Okay, I have some answers as well. Wait, guys.
Hey, Auntie, is my answer correct?
I'm checking. You guys are too fast, you know. No, that. Oh wow, Saket, that's right. Saket, are you doing extra work at home?
No.
Okay, go ahead and explain to us.
Oh, so basically, so you take that's like the total volume of the mixture is like 30 liters. So you do that like, yeah.
Let's write it down. Total
Okay.
volume
Yeah.
of the
Yeah.
mix is 30 liters. Okay.
So like the total amount of acid in the final solution, so it has to be like 60% of like that 30. So
40%
it's like,
acid solution. Let's say the volume is what?
yeah.
Volume is X.
Yeah. So then you do 0.40 x.
We'll come there. We'll
Oh,
come
okay,
there. 70% as a 70% acid solution volume is what?
Why?
That's what I said. You don't need the second variable. You don't need the
So
second.
just X.
This is X, right? Meaning you're adding two different solutions. The 40% solution.
So why?
Not really. The total volume is 30. So how can I say this?
Wait, so then you do like
15?
0. No.
The volume of 40% acid solution is X liters. The volume of 70% acid solution is what if the total volume is 30?
Oh, 3.
Yeah, so then you do 0. So you do those in percentages of 0.40.
Let's not. Saket. I don't want you to. I don't want you to go fast, but I want you to understand 40% acid solution volume that you're going to mix is X. 70% acid solution that you're going to mix. What is the volume of that you're going to mix?
3.
3.
3. How 3?
You wrote 3.
I didn't write 3. I want to finish it. See, the total volume of both should be 30 liters. The
Okay.
volume of this is X liters. What is the volume of this?
Any number between 1 and 30?
So how can I write that?
1 ... 30.
30 minus X liters, right?
Oh, I see.
You see it?
Mm-hmm.
Okay, now go ahead, Saket.
So then you make those into percentages. So you do 0.40 x plus 0.70 y.
0.4
So you just make those in percentages, and then do 0.60 times 30, and then you do 0.4 plus 0 times 7y, and x and y, and then you do those numbers, you multiply them, you get 18. So then you get x equals 30. So then it's like this different part. It's like x equals 30 minus y, and then you do 0.4, and you have to write an equation. Then if you simplify that equation, you get x minus 30, x equals 30 minus 20. If you solve that, you get 10. So it's
Very nice. Okay, that's right. That's the way to solve. So let's see this. How many liters of each should she mix to obtain 30 liter of 60% acid solution? So what do we know? She's finally achieving 30 liters of 60% acid solution. So can I write that? Okay. Finally, she's achieving 30 liters of 60% solution. This is your final, what she's achieving. But for that, she has to mix these two. Now we know the volume here is x liters, here is 30 minus x liters. Now you know what, now you know how are they going to combine? This is 40% of x. Can I write that down like that? I can write 0.4x. Can I write it like that? I add it with what? I add it with what? 0.7?
7, yeah, 0.7 of 30 minus x.
Correct. Right? They both combine to form what?
1.1
Yeah,
No.
Vaibhav, let's finish the equation. The left side, these two are added to get what? 30 liters of 60% solution. How do I write it?
First distribute 0.7
First,
to
let's write
each.
First, let's write the right hand side. We didn't finish the equation. We'll solve the equation later. We'll finish the equation. Left side is you're combining this with this to form
So it has
what?
to equal 30.
30
No,
equal
0.6.
0.6 times
30.
30, right? Basically, what are you equating? The amount of acid content in your 30 liter solution you're equating. Finally, you should have only 60% of the 30 liters as acid. Here, how do you get that? You're combining 40% acid solution x liters and you're combining 70% acid solution 30 minus x liters. So the acid content present in the 40% acid solution is this. The acid content present in the acid content volume present in the 70% acid solution is this. You're combining both to get a 60% of 30 liters is acid. Now, 0.4, how do you do? Vaibhav was telling, everybody was telling, Aradhya was telling, how do you do this?
Distribute.
Yeah?
distribute.
7 3s are 21. So what is this, guys? Help me out, guys. 21 is 21. Okay, minus 0.7x will be equal to 1.8. No. 18, right?
18.
Then what do I do? Minus 0.3 x equal to 3. X will be equal to what? 10.
10.
So you're going to add 10 liters of 40% solution and 20 liters of 70% solution. Was it hard?
No.
Not really.
Not really, but first time it's very hard, guys. It's very difficult to even comprehend what they are saying. So basically 40% acid solution, 70, see this comes only in algebra 1, but it's very easy to write the equation. That's why I gave you. 40% acid solution means you're going to, the amount of acid is going to be 0.4 of whatever volume you have. So 0.4 of whatever volume, 0.7 of whatever volume you have, that you're going to add it to finally get 0.6 of the 30. Make sense?
Yeah.
Miss Priya.
Dutt and Sricharan, you didn't say yes. Did you understand, guys?
Yeah.
Okay, yes, ma, tell me.
I literally just switched up the 10, the 10 and the 20. And I did 20 of the 40% and 10 of the 70%.
That still works.
That still, see, wait, no, that I can't say it still works, but the way you're telling me, I feel like it will still work. See, if this can be taken as x, this can be taken as 30 minus x. But in that case, you should have gotten x as 20, this as 10. You see, that's why I can't say it works in your case. You see, if you take this as x, this as 30 minus x, still the 40% solution should be only 10. 70% solution should be, 40% solution will be 10 liters. 70% solution will be 20 liters. Can I move on?
Yeah.
Okay, guys. Now, I really want to go to angles. I know I'm a little pushy, but okay, let me quickly see. You all know, I'm assuming you all know how to use protractors, right?
Yeah.
Yeah, and the thing is, I wanted to be able to distinguish between basic stuff in geometry, okay? When I want to describe this, what is this?
Array.
What will you use to describe this?
It has.
It has a point that
Array
continues
inside.
forever.
Yeah, it goes on forever, but you need
Yeah.
to have 2 capital letters to describe this. And is this equal
Ray
to
A
this?
B.
Yeah, are they equal?
No.
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 No,
No.
because they are in different directions, so they're not equal. Okay. Now, A is the starting point. This represents this. Okay. The ray BA should have been like this. You got it, guys?
Yeah.
Okay.
Yeah.
Now, what is this? What is this?
A to B.
Line segment.
Yeah, this is a
Oh,
Line
line.
segment AB.
Yeah.
Yeah,
you
line segment AB.
AB. And what is
Line
this?
A, line AB.
Line AB. How do you represent this? AB, and on top you
It
put
has one.
2 capital letters are used to represent that. What is this plane? What is that plane? What is it called?
Hello.
A parallelogram.
Hello.
No. A flat surface is called what?
A plane. A
Plane.
geometric plane.
And usually you can use a capital letter to represent a plane. You got it?
Yeah.
Now coming to, you know what are, let's say I have a cube. You know what are parallel lines?
Yes.
Yeah.
Two lines. Two lines that are across from each other that never touch.
No matter how far you go.
Yeah.
You know what are skew lines?
Yeah.
Yeah.
What?
No.
No.
So there are lines that will end up touching each other.
Oh, okay.
That's all.
Oh, so the opposite of
Not
parallel.
That's it.
In different planes. In different planes. Let's add that. You got it? Let's add that. Can we add that? Go ahead.
I have a question. We learned about skewed lines when I forgot what we were doing. We were doing this type of like graph or something. Aren't like skewed lines that aren't straight, like in one straight pattern? They're like curving or like going in a different direction.
True. Going in a different direction is nice. Skew lines never meet. Okay, even if you extend infinitely, they're not going to meet, and they do not lie in the same plane. Does that make sense? Does it make sense? So practically when talking, right? Yeah.
Yes.
Hmm?
In a cube, there's like 6 sides. So it can be
Faces.
parallel to another side.
They exist in different planes and they are never parallel to each other. Make sense?
All right.
I want to give you some examples. Let me see if I can give you some examples. Let's see. Nice examples. I don't know whether I'll get it. Let's see, guys. BD in front of a cube in the horizontal line EF, P, T, EF. Yeah, that's a good one. Okay, yeah, this is a good one. Yeah. Let me give you this example. These two are parallel. Okay, let me erase my figure. My diagram is so messy. Okay, how about this? Here, when you think about BD on this plane, BD is in the front plane, right? EF is in the back plane. These two are skew lines. Did you guys get it?
Yeah.
Both are on different planes. You see, they are not on the same surface or plane, right?
Hey, what are skew lines again?
Q lines are lines that are never parallel to each other and lie on different planes. Make sense?
Okay.
So here, this and this are skew lines. AC, GH are skew lines. They lie on different planes. Okay. This is the side plane, right? This is the right side plane, right? So for that matter,
Okay, now I get it.
yeah, they should lie on different planes and they should not intersect each other. That's all. Okay.
Okay.
Not a must. Yeah, you just need to know. You just don't say, hey, somebody says skew lines. Don't say, I don't know. Now, coming to definition of angles, right? Let's see this one. Let's see this one. CEBD. Okay. Now, how do you say this angle?
Acute.
Right angle.
Angle
Nobody
CBE.
said that this is a right angle. Vihan, you're too quiet. Why don't you say? Vihan, you're too quiet. Go ahead and say. How do I express this angle?
Acute.
Huh?
Acute.
Acute, amma, that is all fine. But this, like you have a name, right? I can call you Vihan, right? Name the angle. Name the angle, amma. Okay, no problem. Somebody.
Can
I can do it.
CBE?
ECB.
CBE is incorrect.
CEB.
ECB.
Angle
CEB is incorrect.
ECD. ECD.
ECB.
BCB.
ECB.
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 ECB is correct.
BCE.
Finally.
B is correct. BC is correct. So the center should be your angle. Okay, just don't say C. A capital letter can be used to indicate an angle. This capital letter can be used here. You can say the angle C here, but you can't say the angle C here because it can mean the black colored angle or this angle. So you can't say one capital letter to represent the angle in this case. Here you can say, but here you can't use C as the angle.
Is it because there's another angle?
Exactly. So you have to use ECB or BEC like this. Make sense? Okay. Now, let's say, what do you think about this angle and this angle? What are those called?
Very obtuse.
Vertical
No.
angles, like equal angles.
They're all right angles. They're all
Right angles.
right angles.
No. Nobody said they are right angles. Okay. Even if I draw a diagram like this, unless they give me this marking, it doesn't mean that they are right angles.
Are they like, what is it called? Equilateral angles?
They're equal
What's it called?
Angle 1 is congruent to angle 2. This symbol is called congruent. Same size, same shape, same size. Same shape, same size. Angle 1 is congruent to angle 2.
I know what it is. I just don't know what it's called.
So you got vertically opposite angles.
Yes.
Vertically opposite angles.
I got opposite. I didn't get vertically.
Nice. Now can I move on? How about this? Let's say an isosceles triangle. Which two angles are equal in this isosceles triangle?
AB and AC.
Guys, angle you cannot wait. Can I finish?
AC.
Okay, can I talk now? You cannot call angle as AB. That's the main thing. That is why I started this discussion. You cannot call angle as AB. It is not making any sense.
B and C.
ACE.
BA and CA.
Vaibhav, go ahead and say what was that?
I said ACE.
ACE is what?
It's a obtuse angle.
It's an obtuse angle, but I'm asking, I marked that these two are equal, making it isosceles. I asked which angles are equal.
ABC.
B and C.
ABC.
ABC and ACB. ACB and ABC.
Good.
Like
Avi, this can be indicated as B, but this can't be indicated as C, right, Amma?
No, but the reason is because whenever you have opposite, like if this side is equal, like the opposite angle of it would be like congruent. So
So here ABC is congruent to ACB. Can I move on?
So ABC and ACB are both vertically. No, they're not but they're opposite angles.
No, they're
No,
congruent.
no. They're congruent. That's all. They're congruent. They're same shape, same size. That's all.
Okay.
Okay, they're not vertically. Vertically opposite angle only comes when there is an X. Okay. Now, how about this?
Ooh,
The sum of the angles in a triangle add up to what?
180.
Okay. Now I have a. Okay. Before I go
Oh,
here,
Pythagorean theorem.
suppose I have a big pizza. Okay. There are 6 people in my house to share. Okay. Okay. Now tell me, what is the angle of the pizza cut by 4 of us? What is the
Obtuse.
angle of the pizza that 4 of us taken?
Obtuse.
That I know. What is the measure I'm asking, guys?
240.
2 into 40. Why 2 into 40?
Because the whole angle of the pizza is 360,
360.
and then if you do like 4
It's
times
2/3.
60, that's 240. So yeah.
4 times?
2/3 of
360, because like a circle's angle is 360.
Yeah, and then after that,
So there are 6 pieces, right? So I can
60.
Each is
divide by 6.
that's
That is 60 degrees.
Each
And
is
you
60 degrees.
Yeah, that's what I was gonna say. Each is 60,
Yes,
so
Aryan.
you add.
That's what I tried to say.
Yeah.
Me too.
Good job. Yeah. I can hear you. Okay, as long as you know, I'm happy, guys. How about this? Suppose if I have,
Ooh, right angle time. Never mind.
I didn't say that it's a right angle, right? Yet.
That's cute.
Looks
Okay.
No,
How
the
about
angles
this?
are cute.
What is this, guys?
Um,
140.
You can shout out.
240.
40.
240.
No,
What
it's not
is
240. Hang on.
It's
But
140.
I'm getting
Oh
it.
my god.
3 plus
140.
100.
Yes.
140.
100.
140.
140. 140.
Why?
Oh, my bad.
Can I explain?
That's a
Go ahead.
360.
Yeah.
Entire angle is 360. This is 80. This is 140. 360 minus subtract these two, you get 140. Now let's go ahead and work on the angles. Angles in a triangle add up to 180. Do you all know that?
Yeah.
I
Okay.
know. Wait, can I share a special case?
Go ahead.
On a curved surface, a three-dimensional curved surface, angles on a triangle can add up to more than 180. But on a negatively curved surface, 3D, they can add to less than 100.
By curved surface, do you mean hyperbolic planes?
Kinda, yeah, I think so.
Oh, okay.
Hyperbolic planes.
Or actually, it could be something else. I'm not sure if it's hyperbolic planes. That's what I was asking, because like
Like it's a curve in like
Oh.
I don't know, like a sphere surface. That
Yeah, ma'am. Can I go ahead and talk now? Okay, good. How about this? This one is 50. This one is 30. How about this? How much is this?
these angles are cute.
80.
80.
110.
What do you mean?
100.
No, it can't be 80 because it's an obtuse
Wait,
angle.
Wait, I think I
Okay, well, 80.
That's a
So
180.
that's
guys,
100.
wait.
What's 100?
it's
180.
Wait, I should have drawn it
20?
differently. It's not drawn to scale. Okay, this is not drawn to scale.
80 degrees.
80.
This is not drawn to scale.
100.
I think okay. Here's what I
150 degrees.
180.
80 degrees.
Wait,
150 degrees.
Okay, guys, let me stop here.
How is it?
No, it's obtuse.
Let me
It's like
ask you.
on the outside.
Let me ask you.
Yes.
Angles in a triangle add up to what?
180.
180.
This is 100. This is a line. Line is a straight angle. This is 100, then this is 80. So
Bam.
the remote, see, this is an exterior.
I see.
For a triangle, this is called exterior angle of a triangle. This exterior angle is equal to the sum of two remote interior angles. You got it? Why remote? Because this exterior angle does not touch those two interior angles. There are three interior angles for that matter. This is one, this is one, this is one. But the exterior angle of a triangle is equal to the sum of two remote interior angles. Make sense?
Okay.
Neil, did you get it, ma?
Yeah.
Okay, the exterior angle of a triangle can be so many different ways. Okay, this is also an exterior angle of a triangle. So this angle will be equal to what plus what plus what? This exterior angle 4 will be equal to what plus what?
1 plus 2.
So
2 plus 3.
It would be 120.
What?
It's
2
120.
plus 3.
No, Avi, how can you find out the angle? You can never find out the angle here. I didn't give you any detail.
1 plus 2.
1 plus 2 is incorrect. That's not
2
remote,
plus
right?
3. 2 plus 3.
2
Is the
plus
answer
3.
5?
2 plus 3.
yeah.
There is no 5, guys. This is the name of the angle. You can't
Oh,
add these
my
two.
God.
That's okay. Vihan, did you understand Vihan? Huh? Oh,
So remote just means it can't be like touching the
yeah.
exterior
See,
angle.
this is just angle 2. I did name it as angle 2. You cannot add angle 2 and angle 3 and say this is angle 5. Okay, angle 2. Measure may be 30 degrees. See, measure of angle 2 may be 30 degrees. 2 is the name of the angle. You got it? Measure of angle 3 maybe 60 degrees or 70 degrees. We don't know. The measure of angle 2, measure of angle 3. You need to understand this is measure of angle 2. This is angle 2 means the name of the angle. Got it, guys? Now let me ask you more questions, okay? How about this? I'm going to find this one. I just want you to find what is this angle.
Do we type in chat?
Yes, please. Please type in chat, yes. This one I want everybody to get. You want to speed up, Arihan?
What?
You wanted me to speed up? Actually, that's right.
Not now.
Am I correct?
Am I correct?
Avi, I don't think it's right.
Could you explain it more after? I don't really get it.
Yeah, I'm kind of confused.
Miss Priya, can you check if mine is right?
Can you check
Yeah,
if mine is right?
I can check. I can
Can
check.
I know the answer?
If
Neil, I'm waiting for your answer. Arhan,
My
that's not
answer is
correct.
correct. Can I explain it?
That
yeah, can I explain if I'm right?
that you're right. Anybody can explain. I don't have a problem. Sarvata correct.
Miss Priya, is
Viraj,
my answer right?
Viraj, you're slightly incorrect, Mama. I'll check one by one, Ma Aradhya. Everybody talks on top of each other. Nothing works, right? Yeah, Kabir correct.
Can I explain it then?
Sharon, you did not answer the question, guys. Some of you have written it as 130. Not really, Aradhya. Vaibhav correct.
Can I explain it?
Vihan, you got it, but is that the answer? I'm asking only that question mark angle.
Oh.
Yeah,
Is
please
my
you
answer
yourself
correct?
decide who is going to explain this. Anybody who got it right can do. Rihanj, did you get it, ma? Yes, that's
Yeah.
right.
I just sent it.
Yeah, one of you explain. Come on.
Can I explain?
Okay, here, actually, Vibe, we can do this. It's fine.
Okay. Okay, so I know this is a vertical opposite angle, so the 50 degrees would be equal on both the corners of that triangle, and then both of the rest of the sides are both equal. So 50 minus 180, because there's 180 degrees in a triangle, is 130, and they're only asking for 1, so 130 divided by 2 equals 65.
Oh, that's.
You got it?
Yep.
That makes almost sense.
Aket, you got it?
Basically, what happens is whenever they don't give you values for two angles, you can just assume you can split them.
No. Hey, Kabir,
So
that's
they need to
because
be
of this.
opposite.
This marking says x and x are equal.
Oh, okay. Yeah, sorry. I didn't see you put that.
Yeah, you have to, these markings say these two sides are equal. When these two sides are equal, the angles opposite to them are equal because of isosceles triangle. You got it? Okay, now let's move on to the harder ones. How about this? Easy ones you'll be able to do. How about this? There are some difficult ones in the book. You're going to do it, okay? Now, I'm going to go. It's going to take a while, okay? But please listen, guys. It's quite important, okay? These two are parallel lines. See, this marking shows that these two are parallel lines. If I want to mark one more pair of parallel lines, I will use two different arrows then. See, this says these two lines are parallel, these two lines are parallel. There are two arrows, one arrow, one arrow. That says that lines are parallel, okay? Now, I'm going to take up two parallel lines and I'm going to call something called a transversal. This is called a transversal. Why? Because it goes across the two parallel lines, okay? Before I move with anything, right, I really want to name the areas, okay? Right, between the two parallel lines, whatever angles come is called, I have to add the name interior. So this would be exterior. This would be exterior. I really want you to understand the pieces, the parts, okay? Now, suppose if one angle comes on this side and one angle comes on the other side of the transversal, right? Then these two sides, when they switch angles, right? Then that you have to add the word alternate. Okay. But when the angle comes on the same side of the transversal, right? I will add the word same side. Any questions still here?
Okay, I get it.
Okay. Now we are going to go ahead into the real one.
I'm kind of confused on the alternate part.
So one and one, let's say 1 and 2. You see, they are on different sides of the transversal.
Yeah.
Correct? So they're alternate angles. You see, huh?
Oh,
You get it? Okay.
yeah.
Now let's see. 1, 2, 3, 4, 5, 6, 7, 8. It's a lot of confusion, right?
6, 7.
Yeah.
Oh my God.
Now, can you tell me, first we'll start with equals. Which angles are equals? You know, already you learnt 1. Can you tell me about it? We discussed 1 already.
1 and
One
So are
and
1 and
four.
7.
6
Four.
and 6.
6 and
7.
why?
Because they're opposite.
What is it called? I can't hear that opposite.
Alternate angles.
Alternate.
Alternate.
No, they're not. No. What did we study?
Vertical opposite angles.
Vertically opposite angles. Is there any other pair of vertically opposite angles?
Yeah, 1 and 3.
8 and
1 and
5.
3.
5 and 8. 5 and
3,
5 and 8.
8 and 5.
5 and 8 and
4
then
and 2. 1 and 3.
4
1
and
and 2, 1 and 3.
1
1
and
and 3.
guys. Yeah, you can take turns, right?
41.
Okay. You Akshat wanted to present where? Okay, let me see. Vertically opposite angles we are done. Okay. Now let's see what else. 5 and 7. I don't, first let's finish congruent angles. Okay. Now 7 and 4. See, when you think about 7 and 4, what do you think about them? They are in the same place, right? Left side of
They're
the
probably
transversal. Please let me finish. Left side of the transversal, top of the parallel lines. Left side of the transversal, on top of the parallel lines. So what is it called?
side.
Alternate?
Alternate angles?
No, see, they're not alternate. They're on the same side, same position. You
Oh,
see?
Same side angles?
No, they are okay.
same side.
Let me call that for you. Corresponding angles. They're
Oh, that's the word.
corresponding angles are congruent.
So they're vertically corresponding angles.
Corresponding angles means 7 is congruent to 4. Similarly, 1 is
8 is
congruent to what?
congruent to
8
1
is congruent to 2.
5.
1 is congruent to 5. Good job. 2 examples, okay? I'll move on, okay? It will take time otherwise. As long as you understand, it's good. Now, 5 and 3. How can I call 5 and 3 angles? I'm going to talk about 5 and 3.
They're
What
all
did you say about 5 and 3? I told you, right, how to name. You have to add one name of this and one name of this.
Alternate angles?
Alternate Two things you need to add. Alternate.
Alternate interior angles.
Alternate interior angles. Alternate interior angles are congruent. Alternate interior angles are congruent.
Because they're exact opposites.
Yeah, so angle 5 is congruent to angle 3. One more pair of alternate interior angles, what?
1
and 6.
to 6.
4 and 6. Good job. There, Sarvata, are you following, ma? Viraj, are you following? Okay, now I'm going to pick
Yes.
out. Oh, yeah. Viraj, are you following, ma?
Yeah.
Okay, good. Okay, next we did all the equal angles, right? Now let me go ahead and talk to you about 7 and 8. What do you think about 7 and 8? I want them to press.
Exterior, same side exterior angles.
No,
Alternate
or
exterior
exterior corresponding exterior angles.
Wait. 7 and 8 form
They're
what
linear
side?
pairs.
No, but like, how do you Miss Priya, how do you say like not equal? Because like they're not equal because the line is like kind of crooked.
Yeah,
like,
they're not equal, they're not congruent. But then what do you say about 7 and 8? It forms what? It's very clear there. What does it
180.
Forms like
Supplementary angles of the
Guys,
linear
guys,
pairs.
guys, if all of us start talking, right, the class becomes a pandemonium. So shall we cooperate with each other so that one talks at a time, even if it is wrong or right, we listen to that person. 7 and 8 are what? Yeah, somebody said it right. 7 and 8 form a
They're supplementary and they're linear pairs.
Yeah, they're linear pairs. Good job, guys. Because what is that linear pairs? 7 and 8 forms a line, linear. So 7 and 8 form a linear pair. There are many linear pairs. So what do you call 7 plus 8 is what?
7 plus 8.
15.
180 degrees.
7, so angle 7 plus angle 8 make up 180 degrees. So I can say they are supplemental. What are supplemental? What does supplement means?
Like helpful?
Two angles that
Helping.
equal 180 degrees.
Exactly. When two angles add up to 180 degree, they are called supplement. They are called supplement. They are supplementary.
So 5 and 6 are supplementary angles.
5 and 6 are supplementary. 7 and 5 are supplementary. 1 and 4 are supplementary. 3 and 2 are supplementary.
And then 4, 3, and 1 and 2.
4, 3, yes. 1 and 2 are supplementary. Yes. Now, let me ask you. What is the supplement of 80? What is the supplement of 80?
110.
100. What is the supplement of 40?
100.
140.
140. Now, complementary angles are angles.
It would be 40.
Complementary angles are angles that add up to 90 degrees. Okay, so what is the complement of 40?
Yeah.
A 50?
50. Now, Arhan, tell me what is the supplement of 80?
100.
Nice. What is the complement of 10, Amma, Vihan?
The complement of 10 is 170.
Complement. Supplement means they add up to 180 degrees.
40.
Complement of 10.
Yeah.
7.
40.
Complement of 10 is
80?
what? 80. Makes sense, Vihan? Okay, good. Now, that's just for your information because I'm going to give you some word problems when I say the complement of the supplement and 90 degree add up to this. So you need to be able to comprehend these. Complementary angles means two angles add up to 90. Supplementary add up to 180. Okay. Now the complement of an angle, when they say, then it is 90 minus x. Complement of an angle is x. Complement of that angle is 90 minus x. Similarly, what is the supplement of an angle y? Angle
180 minus
minus
y.
y. So supplement of an angle is 180 minus y. Now, with all this apart, we have more to go. We'll finish this, okay? Now we discussed linear pair, right? Now, how about alternate interior? We did not discuss this. Oh my God, here itself we did not discuss this. How about 8 and 1? What are 8 and 1?
Alternate
exterior.
Alternate exterior.
Yeah, alternate exterior angles are congruent. Alternate exterior angles are congruent. Okay. Linear pairs, okay. Alternate exterior angle are alternate exterior, alternate interior, corresponding angle, vertically opposite angle are all are congruent. Now we'll come to supplementary angles. Okay, linear pair is supplementary. What else is supplementary? We'll see. How about 6 and 8? 6 and 8 are
Complementary.
6 and 8 are not complementary. 6 and
The
8 are
linear pairs are supplementary and
Supplement.
they're
not
adjacent.
linear
6 and 8
pairs.
are
6, oh, sorry, 6 and 8, Lama. Sorry. 6 and 3.
6 and 3. Oh, interior.
Same
Supplementary.
side interior.
Interior corresponding angles.
Same side means it's always supplementary. Okay, same side interior angles are supplementary. How about 2 and 8?
Exterior.
Exterior supplementary alternate angle.
Same, there is no alternate mass. Same side, if
Oh,
same side comes, there is no alternate. So same side exterior angles are 2 and 8. 1 and 7 are same side exterior angles. Same side interior angles are 5 and 4. Same side can also be called as consecutive. Consecutive interior, same side exterior angles.
How would 2 and 7 be on the same side?
Sorry, did I say 2 and 8 is what I said, right?
And then you said 2 and 7.
I am sorry if by mistake I said that. 2 and 8 is what I wrote down. 2 and 8 are same side exterior. 1 and 7.
Oh,
1 and 7 are same side exterior. They are all supplementary, guys.
I get it.
Okay.
yeah, I get it.
See, what will happen is they'll give 7 and ask you to find 2. It will be like that. So you need to use all of this to find each angles. This is called angle chasing. It's a very nice thing. Okay, so we did discuss vertically opposite angle, corresponding, alternate interior, alternate exterior, linear pair, same side interior, same side exterior we discussed, right? I think that's it. I didn't miss anything. I think so.
Can one of us share our presentations?
Yeah, please go ahead. Sorry, yeah. Go ahead. I'm going to stop here. Okay.
Rock, paper, scissors.
No, I thought we all agreed that either Akshat or Aradia were going.
Yeah.
Rock, paper, scissors, nothing.
Honestly, Akshat, you go. I don't.
I'll just do share.
Go ahead. Oh, I'll stop sharing. Oh, sorry. I feel like you all enjoy this. Good. Go ahead.
Let me just roll it. What is going on? All right. All right. Why is it taking so? All right. So, am I going to read it, or are you guys going to read it? Because I'm confused here.
You should
Put
play
it in slideshow and you explain it to us.
Yeah, play in slideshow.
Car company. Hey. 7 Bridges of Königsberg by me. Intro. The Königsberg Bridge is what led to what is now known as graph theory. See the picture in the top right. That is Königsberg.
Mm-hmm.
You see a major flaw in its geology that makes this one of the most famous cities in math. You see, a mayor from a neighbor city was obsessed with one question. Which route would allow someone to cross all 7 bridges without crossing any of them more than once? Take a minute to figure it out. I will let you in on a secret. It isn't possible, but that isn't important. It's what this problem led that is. Go to the next page. Remember that mayor from the other town? He wrote to a famous mathematician named Leonard Euler to invent a new field of math. First, Euler thought this had nothing with math. However, the more he did the problem, the more it seemed that it is related to. Euler's answer had to do with a type of geometry that did not exist yet. He called the geometry of position, but later it'll be known as graph theory. He decided that all the land masses from the top right to simple dots, which we now call nodes, with 7 lines or edges to represent the bridges, which allows us to easily count all the degrees of each node, which is how many lines touch each dot. Euler used this to create a theory that applies to all graphs with 2 or more nodes. Euler made a theory behind this called the Eulerian path, which is which is like drawing a picture without lifting your pencil and without going over the same line twice. It can only be done in one of two situations. Situation 1. If every corner of your drawing has an even number of lines coming out of it, you can start anywhere you want and end up right back where you started, which also makes it a Eulerian circuit.
Mm.
If your drawing has exactly 2 corners with an odd number of lines, you have to start at one of these corners and you finish at the other. Now, if you want to make a Eulerian path in Königsberg, all you have to do is remove any bridge. Now, Königsberg isn't on maps. It is now known as Kaliningrad. Us.
What was that last one? Sorry, guys. I was last piece. Can you go back?
Oh.
Last one when you read it out. Go ahead.
Now Königsberg isn't on maps. It is now known as Kaliningrad.
Very nice. Kalin. Okay, very nice. So, okay, guys. Have you heard of this guy Euler?
Oh,
Mathematician.
yeah.
Yeah.
I've heard of him.
Okay. So, what did you understand about graph theory? Each word is each point from where lines come out are called what? See, that's a good one to know. Can you put it in? Why did you take it out?
Oh, my bad.
Yeah, let's see.
I thought lines were like called like nodes. I could be wrong though.
Lines were not called nodes, right? See, that's a good one. Meaning, you're all going to learn graph theory, right? You know, if you learn graph theory by your 12th grade, right, it shows so much of math rigor. I don't know whether schools offer. Some schools do offer graph theory. So so he read it out, right? Go back. Go back to the previous slide. It was clearly given. What are nodes?
Yeah, nodes are like degrees. And he decided that nodes are like kind of like dots and points. Kind of like.
These are nodes.
I'll make this
So
bigger.
points on a graph?
How about I make
the points in a graph? Yes. Yes, he's making it bigger.
Okay.
Right? And nodes, and then what are
Can I watch one of those episodes?
yeah, what are these?
Yes, to me.
the degrees?
The degree of the node. See, this is a node. The degree of the node is 3 here. The degree of this node is again 3 here. The degree of this node is 2 because 2 lines go out of the node. Got it, guys?
I did not explain that one in words, so.
Oh, it was there. It was there when you read. It was there in your paragraph.
But I didn't know how to explain it a lot better.
Oh, that's okay. That you'll get with after you see 7 presentations, you'll automatically get it. So you understand what a node is, what a degree of the node is, okay? From that one, okay? And I want you to know, meaning, what is this E? This guy, this mathematician Euler, right? He brought in the number E. Can you all find what is that E and come back next week?
E is I thought E was like the central like
Isn't
thing of
E, what is it?
exponentials.
Oh
What
my
is
God.
that? Oh, electric
E
potential.
equals-
But Euler was a mathematician. I really appreciate you telling E is electric potential, which is correct in physics. But Euler introduced this mathematical number E. We use it everywhere.
I see it sometimes.
What, so E equals MC squared is the same E?
No, that's
E
different. That is E's
the-
energy is equal to MC square was Einstein's equation, where M is the mass of an object and C is the speed of light. No. I don't want all this. That is theory of relativity from Einstein. Okay, that is in physics. But this guy, this mathematician Euler was very famous. Okay.
Wait,
He
was
brought.
he more famous than Gauss?
What is it?
Was he more famous than Gauss, like Gaussian theorem?
See, they are good in their own ways, right?
Oh.
Yeah. So one is not better than the other, but these were all mathematicians that contributed to what we are learning, right? So, but he contributed particularly this number. There was a number that was named after him, which is called E. So you Google, discover what it is, and come back. So you get to know a little more than the usual math, right? So let's see. It's used in algebra too. So why don't you Google and come? We use it a lot from algebra to pre-calc and all. Okay, any other question? That was very good, Akshat. Very nice.
Yeah, great presentation. I learned a lot from that one actually. I didn't know about like Königsberg and like the 7 notes thing.
Oh, nice feedback. Any other feedback?
Yeah, I think it was really cool. I mean, it's a really cool.
Yeah, it was really cool.
Yeah, it was
and
kind of easy to
Very
understand.
yeah.
I also felt it was easy to understand.
Like how you kept it like simple and like it wasn't like you didn't overcomplicate it. You made it like
He
simple.
didn't put a lot
Yeah.
of mathematical expression, so it made sense.
Yeah, it was nice. Meaning a quick intro to graph theory was very nice. Okay, great. Next week, who wants to do?
Me?
Not me.
Not me.
Okay,
I know
Aradhya
it's
wants
I'll
to
do it.
differences,
I
but
can
I
do it
didn't know.
next week.
But
Aradhya,
Miss Priya,
Yama.
I sent it to you in the 8.3 and 8.3 thing, but my share screen doesn't work. So
Oh, don't worry. I can share for you. Don't worry
yeah,
about it. Okay, yeah. Any
Yeah.
other questions, guys? Hey, next week we have a break. I'll miss seeing you next week, but next week. Okay?
yeah.
Bye, Auntie.
That is happy or sad?
Sad,
Bye,
kind
ma'am.
of.
Bye.
Bye.
Bye, guys.
Miss
Nice
Priya,
class, guys. Yes,
Bye.
ma'am.
is E equal to 2.71?
Yes.
Oh, okay.
718, yes. Is it a rational number or an irrational number?
I thought it was irrational because it never really
Yes,
ends.
no, it ends.
Oh, it does?
Yes, it is a rational number and it ends. It just ends in two. I think it repeats 2 times and stops.
Oh, okay.
I think so. You have to check.
Thank
But
you.
this is very useful in practical applications. Find out in what application practically where do you use this E.
Okay.
Okay, and what is this E? Meaning, no. If you do some calculation, that number reduces to that calculation reduces to the number E. What is it? Where is it used? Yep. Good job, Kabir. Good start. You only started it, right?
Thank you.
Good.
Have a good day.
Bye bye.